Okay, so now let us see how to write the chemical equations. To write the chemical equation first, you must be able to identify what are the reactants that will involve in the reactions and what are the products will form in the reactions. For sometimes the product form, you need to memorize it. Okay, for example, after you run the experiment, you must memorize what is the product will be formed. Okay, for you to write up the equations. Secondly, you must be able to write up the chemical formula. Okay, for the reactant and the product. Third, you must be able to do the balance the chemical equation. So 3 steps to write the chemical equations. Now we look at the first example, 1a. Okay, I'll write the balanced chemical equations for each of the following reactions. 1a, nitrogen gas react with hydrogen gas to form ammonia. So from here, you must identify where is your reactant. The reactants normally always is written in front of the arrow. This is arrow. Now, the reactant will write in front of the arrow. The product will write behind of the arrow. So, after you identify the reactants already, then you need to write the chemical formula. For example, now, nitrogen gas. Now, what is the formula of the nitrogen gas? Chemical formula. So, it is N2. Okay, some gas you need to written in the diatom like hydrogen, nitrogen, oxygen, chlorine, fluorine, bromine, iodine. These substances they always exist as a diatom as in nature. Okay, so when we talk about nitrogen, oxygen, hydrogen gas, chlorine gas, fluorine gas, bromine liquid or iodine solid is always written in the diatom. Okay, so nitrogen gas. Okay, already. Now hydrogen gas. Okay, hydrogen gas. The formula is H2. You must identify the formula first. Okay, ammonia gas. Okay, third one. Ammonia gas is a product. So ammonia gas, the formula is NH3. This one you need to memorize, okay? NH3. So now, after we identify the formula of the reactant and the product, then we try to build the chemical equations. So nitrogen gas, this one, nitrogen gas is N2, react with hydrogen gas is a H2 to form ammonia gas, NH3. Okay, now you already identify the reactant and the product already and the chemical formula. Now we try to do the third step, balance. Okay, how to balance? Okay, to balance it, the number of the atom for the reactant and the product, it must be the same. Okay, here we got 2 nitrogen, 2 hydrogen for the reactant. For the product, nitrogen we have only 1, hydrogen we got 3. 3. Now if you look at the formula like this, the subscript number here, okay, is belongs to the element in front it. Okay. Okay. Now, so now this equation is not balanced. Okay, the number of nitrogen is not balanced, number of hydrogen also not balanced. Now, how are we going to balance it? Normally, we'll balance the equation by making the odd number to even number. For example, nitrogen here is an odd number. So we try to make it into even number times 2. Make it to even. So when you times 2, this 2, you must write at the side stoichiometry here. Okay, don't put it here. Don't put subscript. Subscript is a formula. You cannot change the formula. When you balance the chemical equation, you write the number at the side here. So 2. Okay, so after you times 2, okay, your nitrogen, you have 2. Your hydrogen also times 2. 3 times 2, you got 6. Times 2, you got 6. Okay, hydrogen, you got 6. Okay, nitrogen is balanced already, 2, 2. Hydrogen now is not balanced yet. This one 6, this one 2. So this you can times 3. When you times 3, you get 6. So 6 and 6 balance. So this is the balanced chemical equations. Okay, first one. Now we look at the second one. Okay, first one already, we look at the second one. Sodium metal react with water to produce aqueous solutions of sodium hydroxide and hydrogen gas. So the reactant is a sodium metal and water. The product is a sodium hydroxide and hydrogen gas. Okay, so you identify the reactant and the product. Then after that, we try to find the chemical formula. So sodium metal. Sodium metal. Now, the metal normally is atom. Okay, you write it in the atom form. So sodium is Na. Okay, sodium metal is Na. Like magnesium metal. Okay, metal normally is atom. Like magnesium metal is Mg. Okay, zinc metal is Zn. Okay, copper metal is Cu. Metal is a solid. Okay, normally in solid form, and the formula is atom. Is writing in atom. Okay, metal. Then water. Water, the formula is H2O. I think this one you know already. Sodium hydroxide. Now, sodium hydroxide. Okay, now this one is ionic compound. Sodium, when it is ionic compound, you must find out the ion first. Okay, hydroxide is OH minus. Sodium is Na plus, hydroxide is OH minus. So the ratio is 1 to 1. Okay, so the formula is NaOH. Now, NaOH. Okay. Okay, then the last one, hydrogen gas, is this one already. Okay, now we try to build the chemical equations. Okay, sodium metal is a Na plus hydrogen gas is a water plus water is the H2O. Okay, we form sodium hydroxide is a NaOH and hydrogen gas is a H2. Okay, now we have built up the chemical equation already. Now we try to balance it. We try to balance it. Okay, to balance it, you must balance the number of atoms for the reactant and the product. So here sodium we got 1. Hydrogen we got 2. Here 2. Got 2. Oxygen got 1. Okay. Now this is for the reactant. For the product, sodium you got 1. Hydrogen. This one you got 1 here. Another one is here. You got 2. So 1 plus 2 is 3. Okay, 3. And then oxygen, you got 1. Okay, 1. Now, okay, sodium is balanced. Okay, hydrogen is not balanced. So it's not balanced yet because the hydrogen is not balanced. So try to balance it by making the odd number to even number. So we try to times 2. Okay, we try to times 2. So it becomes 3 times 2 is 6. 6, so times 2. Okay, the sodium times 2 it becomes 2. Okay, becomes 2. Sorry. When we times 2, we need to recount it. 2 sodium, okay? Okay, 2 sodium. Hydrogen now, you got 2 here. Another 2 here. So 2 plus 2 is a 4. It's a 2 plus 2 is a 4 hydrogen. Okay, oxygen, you got 2 here. So 2. Okay, so 2, 4, 2 here. Now, it's not balanced yet. Not balanced. Okay, so sodium here 2, you need to times 2. When you times 2, sodium become 2. Okay, hydrogen here you got 4. So this one you times 2. 2 times 2 is 4. Okay, then oxygen 1 times 2 is equal to 2. Okay, so this is a balanced chemical equations. Okay, all is balanced. Okay, 2, 2, 4, 4, 2, 2. Okay, Now we look at C. Okay, C. Solid copper 2 carbonate. Question C. Solid copper 2 carbonate decompose into solid copper 2 oxide and carbon dioxide gets when heated. So what is your reactant here? Okay, our reactants is copper 2 carbonate. Then it said decompose. Okay, to form solid copper 2 oxide and carbon dioxide. So copper 2 oxide and carbon dioxide, these two is your products. Okay, products. Okay, C. Your reactant is copper 2 carbonate. So we try to find out what is the formula of copper 2 carbonate first. Okay, copper 2 carbonate is ionic compound. Copper 2 is ion with charge 2 plus. Carbonate is CO3 2 minus. Okay, ratio is 2 to 2. Then you can simplify it 1 to 1. So it is a CuCO3. Okay, this is a formula for copper 2 carbonate. Okay, copper 2 carbonate. Now this is a reactant. How about the product? Product is it is a copper 2 oxide. So copper 2 oxide. So what is the formula? So copper 2 oxide. Copper 2 is a Cu2 plus. Oxide is O2 minus. 2 to 2 the ratio. Then you can simplify 1 to 1. So the formula is CuO. Okay, this is a copper 2 oxide. And then another one product is carbon dioxide. Carbon dioxide, I think everybody know it is a CO2. Now we try to write the chemical equations. Copper 2 carbonate is a CuCO3. It decomposes, okay, to form the product copper 2 oxide, CuO, and carbon dioxide gets CO2. Okay, now we try to balance the equations. Okay, for the reactant, copper you got 1, carbon got 1, oxygen you got 3. Okay, for the product, copper you got 1, carbon, we do carbon first. Carbon you got 1 here. Okay, got 1. Oxygen you got 1. This one got 1. This one you got 2. So oxygen you got 3. So O is balanced. So you don't need to balance anymore. Okay, O is balanced. Okay, so this is a chemical equations, balanced chemical equations. Okay, now D. How about D? Burning. Okay, we'll look at questions D. Burning of aluminium powder in excess oxygen produce aluminium oxide powder. Now aluminium powder is a metal. Now here metal. Okay, is a metal. Now metal normally we write it in atom. Okay, as atom. Okay. Excess oxygen. Oxygen, the formula is O2 here. Oxygen is O2. Okay, O2 will produce white aluminium oxide. Now, how about aluminium oxide? What is the formula? Okay, aluminium is Al3 plus. Oxide is O2 minus 1. Minus. Okay, so 2 to 3, the ratio. So formula is Al2O3. Okay, now we try to build up the chemical equations. Aluminium powder is Al plus excess oxygen O2 to form aluminium oxide Al2O3. Okay, now we try to balance it. Okay, for the reactant, aluminium got 1, oxygen you got 2. For the product, aluminium you got 2, oxygen you got 3. So it's not balanced. Okay, not balanced. We try to balance through here. Okay, we try to make the odd number to even number times 2. Okay, so aluminium 2 times 2 it become 4. Oxygen 2 times 3 become 6. Become 6. Now here aluminium, okay, is only 1, so you times 4. Okay, it become 4 aluminium. Okay, now the oxygen, here you got 2, you times 3. Okay, it becomes 6. Okay, 3 times 2 becomes 6. So 4, 4, 6, 6. So this is a balanced chemical equation. Okay. So this is how to build the chemical equations.